Okay. Good morning, students. Long weekend. Holla from the 403 to the HAZ, Mr. Nelson. It's your boy. So I love polynomials. I love this unit. I think it's very logic-oriented. It's just kind of like, well, you'll see it becomes just like really basic puzzle solving with numbers. And who doesn't love puzzles? Who doesn't love numbers? Not this guy, he loves them. I think that made sense. In any case, in the last video, when we started talking about polynomial factoring, the method we started working with, which should be kind of the first step in any factoring scenario, was just finding common factors and then pulling them out, okay? So let's just look at what that looked like, just as a quick reminder. So if I had something like 6x squared y plus 3xy squared plus 9x cubed y cubed. So I would break this up into each term separated by a plus or a minus, and I would find the common factors on each of them. So 6x squared, I would rewrite as 6x squared y, and then I would factor each. So 6 would factor down to 3, which is a prime number, and 2. X would factor down to 2 x's, and then y is already prime. So then 6x squared y would be 3 times 2 times x times y. 3x y squared would factor down to 3 times x times y, and then 9x squared x cubed y cubed would break down into 3 times x times y times y times y. 3 y's for the y cubed. And then I look at each broken down expression, and I look for common. So they all have a 3 in common, just one 3, that is what they have in common. There's no 2's in common. They all have at least one x, so they all have one x in common, and they all have at least one y, so they all have one y in common. So I can pull out what they have in common, which is a 3xy. So I pull out a 3xy, I open the bracket, and I put whatever's left. So I have 2x, that's going to make my 6x squared y, plus just a y, plus 3x squared y squared. Because there's 2 x's there, so it's x squared, y squared. And then this would be factor. That is glorious. So this is the first step we should always be doing in any polynomial factoring situation, is first checking if we can pull anything out and simplify, and then factor it that way. And then we might get to a point where, yeah, we've pulled something out, but then we might be able to factor this further. How, you ask? Well, I'll show you. So we're getting rid of this. So the next step, potentially, another tool in our breadbasket. That made no sense. Another tool in our toolbox would be a method called product sum. Okay? Probably the most common type of factoring you're going to be asked to do, at least in the foreseeable future. Product sum. Me likey. It's very nice. So what if I gave you something like, or what if you were given an expression like x squared plus x plus 5x plus 6. And I said factor this. Well, you would look at this and you'd be like, there is absolutely nothing that any of these 3 components of the expression have in common. I can't pull out anything. I can't pull out any x's because there's no x's there. I can't pull any 3's or 2's here because there's nothing here. So then you'd be like, okay, well, I guess I can't do anything else. Wrong. This is where we do what we call product sum factoring. And how does it work? Well, it works like this. Every time. And we'll get to the situation. When we don't have a number in front of our squared term here, this is how it works. When we don't have a number in front of this term. When it looks like this, when it's naked here in front, this is what we can do. We ask, what are two numbers that multiply to make positive 6, and then also add to make positive 5? Okay, we multiply to get the last term without any variables, and add to get the middle term. So I go through it. Well, what multiplies to make 6? 6 and 1. 6 times 1. And then 6 plus 1 is 7. That doesn't make 5. So this is not right. Wrong. How about 1 times 6? Same thing. Gives me a 7. Wrong. What else makes 6? Well, 3 times 2. And 3 plus 2 makes 5. Ding, 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 ding. So then what I can do is I can just rewrite this like this. 2 brackets, because this is a trinomial. And there's going to be an x on each side, and then that's a plus 3, that's a plus 2. So I can write x plus 3, x plus 2. Or I can write it x plus 2, x plus 3. Both situations are exactly the same. It doesn't matter whether I say 3 times 2 or 2 times 3. They're going to give me the same answer. Just like this, it doesn't matter if it's just a pure multiplication, multiplying here. It doesn't matter what order. So I can switch the terms. And we'll see that if I went through and I expanded, say this one here, and I did the multiplication where this guy visits each person, this person visits each person, I would get x squared plus 3x plus 2x plus 6. And then if I collected my x's, I would get x squared plus 5x plus 6, which is there. So this is the factors here, x plus 3 and x plus 2. That is product sum. So let's do a couple more examples with product sum. And we're going to keep using our table here. Our table is important for keeping us organized. Okay, so let's try something like this. I have x squared plus 7x plus 10. So again, I want two numbers that are going to multiply to this last term, so positive 10, and add to plus 7. So let's start her off. Multiplying to 10, 10 times 1. 10 plus 1 is 11. No bueno, no good. 1 times 10, same thing. No bueno, no bueno. What else makes 10? 5 times 2, 5 plus 2 is 7. Whoops, wrong color, 7. And that is ding, 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 ding. And it doesn't matter what order, 2 times 5 will give 7 as well. So I can write this as x plus 5 times x plus 2. Or I could write it as x plus 2 times x plus 5. And then when I go through and do the multiplication, I'll do it on this one here. I get x squared plus 5x plus 2x here plus 10. I collect my x's, I get x squared plus 7x plus 10. Okay, great. Let's increase complexity slightly. Slightly, ever so slightly. I'll get my table ready again. Okay, so far in my equations I've had no negative. So now what happens if I say x minus 6? Okay, so I need two numbers that multiply to make negative 6 and add to make negative 1. So negative 6 adding to negative 1. Well, what makes a negative 6? Positive 6 times negative 1 will give us negative 6, and then 6 minus 1 gives us positive 5. Not negative 1. That's not right. So I can try positive 1 times negative 6. And that gives me negative 5. Still not negative 1. Okay, well I can try positive 2 times negative 3. That'll give me negative 6. 2 minus 3 is minus 1. That's right. If I would have done plus 3 times negative 2, that would have given me negative 6, but this would have given me positive 1. So this is not right. It has to be this exact scenario, plus 2 and negative 3. So if that's the case, I do this thing again, and I get x plus 2, x minus 3, or x minus 3, x plus 2, same thing. And then if I go through and do the multiplication, just to check my work, make sure that I did it right, I get x squared plus 2x minus 3x minus 6. And then I combine my x's, I get x squared minus x minus 6. Okay? Let's do another one. So let's try x squared plus 3x minus 18. Okay, so fill up my chart. I need two numbers that multiply to make negative 18 and add to make positive 3. So what two numbers multiply to make negative 18? Well, we can do 18 times negative 1. And 18 plus negative 1 is 17. Way off. And so if I do the opposite, negative 18 times positive 1, I'm going to get negative 17 here. Times positive 1. So that's way off. So what else makes 18? 9 and 2. So let's try positive 9 times negative 2. 9 minus 2 is positive 7. And so the reverse, negative 9 times positive 2 is negative 7. In any case, all four of these are not right. What else makes 18? So I've done 1, 2, 3 times 6. So let's do negative 6 times positive 3. Negative 6 plus 3 is negative 3. Okay, so I've got the right value, just the wrong sign. So let's reverse it here. Positive 6 times negative 3. 6 minus 3 is positive 3. This is what we're looking for. This is the winner right here. So I can write, again, x plus 6, x minus 3. Or, again, x minus 3, x plus 6. Doesn't matter the order. And then if I go through and I do the multiplication here, I get x squared minus 3x plus 6x minus 18. Those combine to give me a plus 3x minus 18, which is correct. So I did my factoring. These are correct factors. Okay, not so bad. Let's just we'll do two more examples here. I'm just going to rewrite my table here. So add, multiply. So let's try x squared minus 8x minus plus 12. Okay, so I need two numbers that multiply to plus 12 and add to negative 8. Interesting. Well, what? If I use positive numbers here, so if I did 12 times positive 1, that's going to give me 13. If I do 6 times positive 2, that's going to give me positive 8. So, okay, well, if I did 3 times 4, positive 4, I'm going to get 7, positive 7. I'm always getting positive numbers. So how can I get a positive 12 but a negative number there? You guessed it. I'm going to use two negative numbers, because two negative numbers multiplied together makes a positive. And so I'm going to use the 6 and the 2 because they gave me the right magnitude of this number, just the wrong sign. So if I did negative 6 times negative 2, that's going to give me positive 12, and when it adds, it's going to give me negative 8, which is exactly what I want. So using two negative numbers to give me a positive when I had this negative term was the only way to do it, because I can either only use two positive numbers, which will never give me a negative, or I'm going to have to use two negative numbers, which will always give me a negative. So this was a hint here, that I had negative and positive would be that I'm going to have to use two negative numbers multiplying. Hope that made sense, because in this case, I'll get, so when I write this out, I'll get x minus 6, x minus 2, or x minus 2, x minus 6. And when I go through and do the whole multiplication, I will get x squared minus 6x minus 2x plus 12. Negative 6, negative 2 is going to give me minus 8x plus 12. Okay, so let's do one more just like that, and then I'll send you off to go and flourish, my little ducklings. Okay, so let's say somebody yelled at me for always using x's, and they're absolutely right. It's 2019, you know? I've got to use the other letters in the alphabet. 2019. I'm being a mathematical bigot. So let's try m squared minus 10m plus 21. Okay. So let's fill up my chart. Taking some time here, perfectionist. So multiply to positive 21, add to negative 10. So here I have this case again where I have a positive number here but a negative number here. No two positive numbers multiplied together are ever going to add to make negative. So this is going to have to be constructed of two negative numbers. So what makes 21? Well, negative 21 times negative 1, and that gives me negative 22 when added. 21 divided by 2? No. Divided by 3. Negative 7 times negative 3. Adding those together, that gives me negative 10. That is right. So then my answer here is m minus 7, m minus 3. And or m minus 3, m minus 7. And when we go through and multiply, we'll find that it gives us this. So this is the product sum method, super important, and at least in grade 10, but it's one of the most common factoring techniques that we'll use with polynomials. It comes up again and again and again, and it's going to follow you throughout high school here. So occasionally, we will get into a situation where we're going to have to first pull out some common factors, and then we'll be left with something that we can use the product sum on. So a situation like that might look like 3x squared minus 3x plus 18. Okay? So in this case, you look at it and you ask, okay, can I factor anything? Do they have anything in common here? Well, 3x squared is broken down into 3x times x. Negative 3x is, or just 3x is 3 times x. And then 18 breaks down into 2 times 9, and then 9 breaks down into 3. So 2 or 3 times 3 times 2. So across all three of these, what I have in common is 1, 3. So I can break this into, I can rewrite that as 3. I'm going to pull out this 3, open brackets, and then I'm going to be left with x squared minus x plus 6. Sorry, that should be minus 18 there. My bad, guys. Minus 6. Okay? And so I look at now this thing here, and I can't factor this further, but I can try my product sum to see if I can factor that down further. So I have x squared now minus x minus 6. And in my product sum, I say, okay, two numbers that multiply to negative 6 and add to negative 1. Well, negative 6 times positive 1 gives me negative 5. No. Positive 3 times negative 2 gives me negative 6 and gives me positive 1. Okay, I'm close because that's the right number, just the wrong sign. So let's reverse it. Negative 3 times positive 2. So I can break this part into x minus 3, x plus 2, or x plus 2, x minus 3. Therefore, this completely factored, I have to remember that I have this 3 in front, is written as 3 x plus 2 x minus 3. Or 3 x minus 3 x plus 2. Just changing the order. Okay, so that's when we combine our common factors with our product sum. Now the next step is going to be looking at the cases, and it's a similar situation. We play it similarly, is the situation when we have a scenario like this, but we can't pull out any common numbers. So say I had something like 2x squared plus 7x minus 3. Okay? In this situation, I cannot pull out any common factors, and I have a number in front of my x squared, so I can't use the product sum in this way. I have to use a method called decomposition, and that's what we'll be learning in the next video. And then once we have these 3 tools in our toolbox, we're pretty much good to go and solve most factoring problems in grade 10.